So in this first problem, it says in standard coordinate plane, what is the slope of a line parallel? So if two lines are parallel, it looks like this. They rise or fall at the exact same rate. They rise or fall at the exact same rate. So when we think of a straight linear line, if they are parallel, they will always have the exact same slope. And the slope can be found as a number that's attached to the x. So the slope of this line is 1/2. It rises at a rate of 1/2, up 1 over 2, up 1 over 2. So if another line is parallel to this, it will also rise at the same rate, up 1 over 2. In a problem like this, I recognize what they're going to want me to do is FOIL. I want to do the least amount of work and still get the answer. So I start with the front. So 5x times 1x is 5x squared. Anything without a 5x squared, I would cancel. Then I'm going to do the outside and the inside. So the outside and the inside look like this, like two rainbows. 5 times -3 is -15 with an x. Positive 2 times x is a positive 2x. When I cancel, I get a negative 13x. Anything that does not have a negative 13x is canceled. There's only one correct answer. In number 3, I want to figure out what is this. What's this computation? 8 minus 5 is 3. There's the subtraction sign. 5 minus 8 is -3. A common misconception is to try to distribute this negative through the absolute value. Can't do that. Remember, absolute value means what's the distance from 0 to this number. So for those of you that are visual learners, here's 3, here's -3. So how far is it from 3 to 0? It's a distance of 3. How far is it from -3 to 0? Oh, it's a distance of 3. 3 minus 3. I can definitely see with limited time how number 4 would seem overwhelming just to read. When we break this down, it doesn't seem as bad. So it says that each one of these expressions represents an integer value, excuse me, and they're in consecutive order. So this is like one number, here's the next one, right, in order. And together these add up to 511. So if I add up all of the parentheses, they add up to 511. Let's solve for x. 1, 2, 3, 4, 5, 6, 7. There's 7 x's. Now, could I use mental math to add up the numbers without x's? Sure, I could, but I'm going to do it quicker on a calculator. So -2 plus -1 plus 1 plus 2 plus 3 plus 4. Added them up, and I got 7. So when I combine like terms here, I get 7, and it says the sum of these adds up to 511. I subtract 7 to the opposite side. 7x equals 504. I grab a calculator. I'm not going to try to do long division. 504 divided by 7. The correct answer is multiple different ways to go about looking at number 5 and completing number 5. We could take one by one, and this would be a slow method, but you could plug in 8 for x and plug in 8 for x again and see, does this equal 12? If it does, you're like, oh, this could be an answer, and then you have to check 12. Now plug in 12, does it equal 12? That would take a long time to go options A through E until you found one that had two numbers that worked. So I think a quicker way is to move the 12 over to the left-hand side in this particular problem. Now nothing's on the right-hand side. Easy factoring. What multiplies to equal 12 and combines to give you 4? X plus 6 and x minus 2. Now a common mistake when students are rushed to go, oh, the answer is 6 and the answer is -2. Remember, what is the solution to this? It's the opposite. So really we're taking this and setting it equal to 0 to get -6 and to get +2. Correct answer. To understand problem number 6, you have to understand perfect squares. So I'm going to write down the perfect squares all the way up through 144. I'm going to try to show you two different ways to do this problem. Okay, so what this says is, hey, some number exists between 11 and 12, so like 11.1, 11.2, 11.3 for instance. And we want to know which one of these, if I plugged it in, would be between 11 and 12. Now here's the slow way. You're welcome to watch this. I could do the square root of 23. Nope, not in between 11 and 12. Square root of 121. Not between 11 and 12. Equal to 11, but not between it. And then you go the square root of 140. Oh, that's between 11 and 12. That would be one way to do this. Algebraically, I know that 11 squared is 121. 12 squared is 144. I'm looking for any number that's between 121 and 144, not equal to them. Only one of them exists. So a lot of students see that and are like, oh, I kind of get it, but is there another problem we can practice like that, Miss Bradley? So if I was going to make up another problem like this and I said like in between 4 and 5, okay? So if this was the case, I'm just making up another problem. 4 squared is 16. 5 squared is 25. So I would look at the list I had, and I'd look for any number that was like square root of 17, square root of 18, square root of 19, all the way up to the square root of 24. Any one of those numbers would land between 4. Number 7 says x and y won't equal 0. And we just simply want to take this and figure out which one does it simplify to. So I'm going to look at the x's, and I'm going to focus on their exponents. So 7 subtract 2 is, sorry, my fault. 4 subtract 2 is 2. The higher exponent was on top. Now I'm going to do the y's. 4 subtract 2 is 2. The larger one was on the bottom. To be able to do this problem, and it does seem a little wordy, know that this is quadrant 1, 2, 3, and 4. I was taught like make a large C, capital C, and as you go through it, you're going to count. So there's 1, 2, 3, and 4 using Roman numerals. So what we know here is we want to know what possibilities. If we know that at least one of the coordinates is positive, where could it be? So let's think about our x's. Like here, x is positive and y is positive, right? Positive, positive. Over here, you have to go negative first, and then up is positive. Here is negative, negative. Here is right is positive, down is negative. So it says it has to be in one of the coordinates. It's not actually going to be on the line. It has to be in one of the coordinates. And we want to know what coordinates could it be in if at least one of them is positive. So they both could be positive or at least one. It could be in 1 because at least one of these is positive. It could be in 2. At least one of these is positive. It cannot be in 3. It could be in 4. So it could be 1, 2, or 4.